Welcome to The Explainer. Today we're stepping right onto the floor of a virtual data factory. We're going to explore this really fascinating GitHub repository created by a developer named Manish Koti. And by looking at this code, we're going to see exactly how raw inputs get systematically transformed into actionable, predictive insights. So if you've ever wondered how machine learning pipelines actually organize their workflows from start to finish, well, you are absolutely in the right place.
Think about this for a second. Can we actually predict a student's final exam score before they even set foot in the exam room? Before they even pick up a pencil? That is the deeply human stake at the center of the repository we're looking at today. Because you see, this project isn't just about reading lines of Python. It's about understanding the underlying mechanics of success and seeing if we can literally map human behavior into mathematical certainty.
Okay, let's dive right into our blueprint for today. We're going to cover 1. The prediction problem, 2. Setting up the environment, 3. Running the pipeline, and 4. Understanding the outputs. Starting off with Section 1, the prediction problem.
Every great data engineering project starts with a crystal clear objective, right? Here, the developer's core equation is attempting to link study habits, along with a few other related factors, directly to a student's final exam score. So the ultimate goal of this pipeline isn't just writing clever algorithms for the fun of it, it's about solving a tangible real-world problem by finding the statistical correlation between how a student prepares, their habits, their daily routines, and the grade they actually end up getting. It's really about turning everyday behavior into a measurable data point.
Now, to actually solve this prediction problem, the repository uses a linear regression model. You can think of this as the main engine of our data factory. Linear regression is this foundational statistical machine learning model, and it's designed to take those inputs we just talked about, the study habits and related factors, and draw a mathematical line of best fit to estimate or predict the continuous output, which, in our specific case, is that final exam score.
Moving on to Section 2, setting up the environment.
Before we can even think about firing up that predictive engine, we have to meticulously build our factory floor. And now, what's really interesting about this is how methodically the developer preps the machinery. Step 1, we have to make sure Python 3 is installed, because that's our base operating language. Next, for Step 2, we use V&M to create and activate a virtual environment. This is essentially building a clean room for our code, completely isolating it from the rest of the computer. Step 3 is installing all our specific project dependencies from a requirements.txt file. And finally, Step 4, loading our raw materials. The pipeline needs us to place a specific raw dataset called student_performance.csv right into the data directory. Without that raw material, well, the factory literally has nothing to process.
Which brings us to Section 3, running the pipeline.
All right, so we've built the clean room, we've loaded our raw data into the right folder, and now it's the exciting execution phase. Time to flip the switch and turn on that predictive engine we just built. The documentation actually gives us 2 parallel options to execute the entire data processing and modeling pipeline right from the root directory. On the left, we have a simple shell script execution, run.sh. This is a fantastic shortcut that's pretty common in data pipelines to just automate the whole run process. Alternatively, on the right, you can directly invoke the main Python script yourself by typing python3/src/mainpy. Honestly, whichever command you choose, you're triggering the exact same end-to-end automated process, taking that data from its raw state all the way to a finished model.
And finally, Section 4, understanding the outputs.
Okay, the scripts have finished running, the processing is completely done, and we're finally ready to peek into the output directory and inspect the finished goods our machine learning factory just produced. And this brilliantly illustrates the complete lifecycle of our pipeline's data. You see, instead of just spitting out one single answer, the system generates 5 distinct, highly organized artifacts in that output folder. First, our messy raw data was transformed and saved as a filtered cleaned_data.csv. Then, the system outputted the actual brain of our operation, the trained model itself, saved as linear_regression model PKL. Alongside that, it generated a model coefficients.json file, which details the exact mathematical weights and intercepts it learned. We also get a predictions.csv file showing exactly what the model guessed for our test set of students. And finally, the whole shebang wraps up with an evaluation metrics.json file.
Now, focusing on that last file, so the crucial point is that a professional machine learning pipeline doesn't just make a bunch of guesses and walk away, it actively grades its own homework.
This JSON file contains evaluation metrics, specifically mean squared error, or MSE, and R-squared metrics. These specific numbers are absolutely vital. They measure the model's accuracy, and they tell us unequivocally if our factory's predictions are actually reliable or if the model needs to be retuned.
As we wrap up our exploration of this repository today, I want to leave you with this final provocative thought. If a beautifully structured linear regression pipeline like this one can successfully predict final exam scores based simply on study habits and related data, what other hidden factors and behaviors in our daily lives could this exact same modeling structure uncover? Thank you so much for exploring this data pipeline with me. Until next time, keep analyzing the systems around you.